Assalamualaikum and good morning doctor. My name is Noliana I'm binti Mak Ibrahim. Matric number BR191110003. I will present computer research about effect of galax on growth and food nutrition, composition of okra, Arbonaceous escalatus. Introduction. Okra Arbonaceous escalatus, much a member of Malvaceae family, is a fruit vegetable that is widely grown in Nigeria. Okra is also known to contain mineral elements that are necessary for human growth and development, as well as the mineral composition on the plant, organs, and products often varies with the cultivar grown, the environment, the season, and the cultural treatments, including weed control method. Methylbromine is the constituent of galax and is a photosynthetic inhibitor, and there are significant increases in protein content of okra foods treated with methyl lacquer and alacor compared with permethrin and terpentrin. The study found to observe the effect of galax on food yield and food nutrient composition of okra. Methodology. There were seed each of 1.50 meter multiple 2.5 meter with a path of 1.0 meter in between. In each replicate and adjacent replicates were separated by a path of 1.0 meter. For herbicide treatments, there are 1.5, 2.0, 2.5, and 3.0 kg per hectare were compared with 2 and 3 and at 3 and 6 weeks after for planting the WAP and untreated control. A random sample of 10 fruits per plot was dry with an oven at 70 degrees Celsius and ground before chemical analysis. Ground samples were digested in a 2:1 perchloric acid triisonitrate with acid mixture in a fumed carbon. The herbicide rates were selected show that okra could tolerate 2.5 kg per hectare of galax. Herbicide application was made pre-emergence with a knapsack sprayer calibrated to delivery 250 liters per hectare spray solution at a pressure of 2.1 kg cm. Data collected: the ammonium phosphate DAP seedling survival, plant height, number of flowers, number of fruits, fresh fruit yield, and nutrient. A randomized complete plot design (RCBD) was replicated 4 times was used for the two study. All data collected were subjected to analysis of variance and means were separated by using the least significant difference at 5% level of probability. Result and discussion. Emergence of okra seed at 5 days after planting DAP was not affected by Galley's treatments, and at 5 DAP plants under the two consoles and 1.5 kg per hectare were normal and healthy, while those under 2.0 kg per hectare suffer self-phytotoxicity, and those under 2.5 kg per hectare and 3.0 kg per hectare were completely killed. Plant height, flower number, and fruit number were significantly affected by Galax treatment, and the and fresh fruit yield at 1.5 kg per hectare was not statistically different. The untreated control had the statistically significant lowest yield, and application of 1.5 kg per hectare led to significant increases in calcium and potassium content of okra food, while the nitrogen content of the untreated control was significantly lower, and also the phosphorus and iron content were not were not significantly affected by the treatment. Table 1 shows the effect of different concentration of galax on agronomic traits and food yield of okra. Statis- Statistical analysis show that the emergence count of okra seedling and at 5 DAP was not affected by the herbicide treatment, and this shows the galax is not a contact poison to okra seed. The seedling survival at 5 DAP was significantly affected by galax treatment both in 1992 and 1993 trials, and okra plants under 2.5 and 3.0 kg per hectare were completely killed at 5 GAP, while those under 2.0 kg per hectare were reduced. At those under 1.5 kg per hectare, untreated control and at 3 and 6 WAP were normal and healthy, as well as the surviving plants under 2.0 kg per hectare show static and yellowing indicating phytotoxicity. The number of flowers per plant was significantly affected by Galley's treatment both in 1992 and 1993, and the lower number of flowers produced by untreated plants could be attributed to competition between okra plants and wheat for nurturing gases, light, and moisture. The lowest number of flowers obtained for 2.0 kg per hectare plants could be attributed to self-phytotoxicity induced by the herbicide. For the 2.0 kg per hectare plants produced flower, not fruit, was produced as flowers aborted before buds could open, and significantly lower number of fruit was produced by untreated control compared to 1.5 kg per hectare and at 3 and 6 WAP. Table 2 showed the effect of different concentration of galax on okra food nutrient composition on percent dry matter basis, and there were no significant difference in phosphorus and iron content of okra food, both in 1992 and 1993. The 1.5 kg per hectare and H3 and 6 WAP plants did not differ significantly in the nitrogen and crude protein content but were significantly higher than the untreated plants, and generally the untreated plant leaves were yellow indicating poor light interception in part and natural deficiency, especially nitrogen in other parts. The calcium and potassium content of okra foods under 1.5 kg per hectare was significantly higher than the untreated control and S3 and 6 WAP both in 1992 and 1993 trial. The 1.5 kg per hectare plants produced 4.9% and 1.7% increase in average calcium content compared to untreated control and X3 and 6 WAP respectively, while the average potassium content was 38.0% and 25.8% higher in 1 kg per hectare than the untreated control and X3 and 6 WAP plant. Conclusion. In conclusion, okra reacted sharply to increase in galax concentration between 1.5 to 2.0 kg per hectare. It is recommended that rates higher than 1.5 kg per hectare should be avoided for okra, and also calcium and potassium content of okra was significantly increased by galax treatment, and however, the effect of galax, if any, on human health and a study of the chemistry of garlic additive is recommended. Take-home message: herbicide treatment need not have any significant effect on okra carbohydrate, protein, moisture content of or fruit quality, but the results in this study were vary, and this may be due to differences in the tested herbicide and garlic tested, as well as the variety stated, and also different study environments. Therefore, it can be concluded that Galax or its additive may not inhibit the growth and yield of okra but instead increase the uptake from the soil. This is a reference for this journal. Thank you. That's all.